What if the aircraft keeping entire regions of Russia alive, literally keeping them connected to the outside world, was slowly dying? And what if the country that built it had to start completely from scratch? Under sanctions, under pressure, against the clock. That's not a hypothetical. That's exactly what's happening right now. Hit subscribe and turn on notifications, because this story is only getting bigger. Let's get into it. To understand why the LMS-901 Baikal matters, you first have to understand the aircraft it's replacing. The Antonov An-2, a biplane, first flown in 1947, nearly 80 years ago.
No presurización.
No modern avionics. Fuel efficiency that would embarrass almost any contemporary design. By every objective engineering standard, it should have been retired decades ago. And yet, it's still flying. Across Siberia, across the Russian Far East, across remote steppe communities that have no roads, no railways, and no alternatives. The An-2 lands on grass strips, gravel paths, frozen riverbanks, in conditions that would ground almost any other aircraft on Earth. For thousands of people in these communities, the An-2 isn't transportation. It's the difference between having access to the world and being completely cut off from it. So here's the real question. Why hasn't Russia replaced it sooner? Because the An-2 is brutally difficult to replace. It occupies a very specific niche that demands short takeoff capability, extreme durability, and the ability to operate with minimal infrastructure. Building something better is genuinely hard. Russia has known it needed a successor for years. The debate wasn't whether, it was how, when, and who. That answer has taken longer than anyone expected. But in April 2026, something finally changed. The LMS-901 Baikal. The name itself is deliberate, named after the world's deepest freshwater lake, sitting deep in the Siberian heartland, the very region this aircraft exists to serve. It's a single-engine turboprop, compact, capable, and purpose-built for Russia's most challenging terrain. Unprepared airstrips? Handled. Extreme cold? Designed for it. Minimal ground infrastructure? That's the whole point. On paper, the concept sounds straightforward. Take everything the An-2 did well, strip away its Soviet-era limitations, and rebuild it with 21st century engineering. But here's the catch. Designing an aircraft is one thing. Proving it is ready to carry real passengers in real conditions year after year, that's an entirely different battle. And in April 2026, that battle officially began. Certification trials started. Now, don't let that phrase fool you into thinking this is just paperwork. It isn't. Certification trials are where engineering ambition collides with brutal, uncompromising reality. And only the aircraft that survives both walks away cleared for service. So what does that process actually involve? And why does it carry so much risk? Here's something most people outside aviation don't realize. An aircraft being built is not the same as an aircraft being proven. A design can look flawless on a screen, can pass internal reviews, can even survive initial test flights, and still fail certification, because the standard isn't whether the aircraft works, it's whether it works reliably, predictably, and safely every single time across its entire operational life. That's a far higher bar. The organizations overseeing this process for the Baikal are TSAGI, Russia's Central Aerohydrodynamic Institute, and the Russian Aviation Register. These are not rubber stamp bodies. TSAGI carries decades of serious aerodynamic research. Their standards are rigorous, their reviews are thorough, and their approval cannot be rushed. The process itself is deliberately iterative. Engineers test a system. A flaw is found. They go back. They redesign. They test again. The cycle repeats until the aircraft demonstrates full compliance. Not on a good day, but consistently across a wide range of conditions. One failed test doesn't kill the program. But a systemic failure, a deeply embedded design problem discovered halfway through, that can set the timeline back by months, sometimes years. And with the pressure this program is under, every month counts. This is exactly why the spring 2026 testing phase is being watched so carefully. But what's actually being tested right now, And why does it matter so much? One of the most demanding tests currently underway is ground resonance testing. And to appreciate why engineers take this so seriously, you need to understand what resonance can actually do to an aircraft. Every physical structure has natural frequencies, specific rates at which it prefers to vibrate. When an external force matches one of those frequencies, even a small input can amplify into a violent, self-reinforcing oscillation. Think of a wine glass shattering from a sustained musical note. Now scale that up to an aircraft fuselage traveling at speed. You start to understand why resonance failures have been behind some of the most catastrophic moments in aviation history. This is where everything can go wrong, silently, invisibly, and fast. Ground resonance testing maps the Baikal's complete vibrational signature. Engineers attach precision sensors across the entire airframe and subject it to controlled vibrations, carefully recording how every section of the structure responds. The goal isn't just to find problems, it's to build a detailed dynamic model of the aircraft's behavior, so designers can guarantee that no real-world operating condition ever pushes the structure close to a dangerous resonance point. At the same time, the control systems are being analyzed dynamically. How does the aircraft respond to pilot inputs at different speeds? Is the response smooth and predictable, or does it become erratic near the edges of the flight envelope? For a plane flying into remote Siberian conditions with minimal nearby maintenance support, that predictability isn't a preference. It's a survival requirement. But structural integrity is only part of what's being put to the test. There's another layer, one that's far less visible and just as critical. Modern aircraft are, in many ways, flying computers.
Navigación.
Communication, flight control, engine management. All of it depends on a vast network of precisely routed electrical cables threading through every corner of the airframe. And right now, the Baikal's entire cable network installation is being carefully inspected as part of certification. So why does this matter so much? Because electrical failures in aviation are rarely dramatic on their own. They're insidious. A cable routed too close to a heat source, an insufficiently secured connector, a microscopic crack in insulation. Any of these can create intermittent failures, the kind that are maddeningly difficult to diagnose and potentially catastrophic at exactly the wrong moment. Certification standards require that every cable matches design documentation exactly. Insulation verified. Every mount point confirmed secure. The entire network proven resistant to the vibration and temperature extremes an aircraft encounters across its operational life. It's painstaking, unglamorous work, but this is the kind of precision that separates aircraft that fly safely for 20 years from those that don't. With structural testing advancing and electrical systems being validated simultaneously, the Baikal is converging toward a defining moment. One that the entire program has been building toward. But before we get there, we need to talk about what's actually powering this aircraft. Because the propulsion story is where things get genuinely interesting. The Baikal is powered by the VK-800SM turboprop engine, domestically developed, designed from the ground up for regional efficiency, paired with the AV9001 propeller, together forming a propulsion system specifically optimized for the kind of low-altitude, short-range operations that define Russia's regional aviation network. Here's what makes this particularly significant. Both the engine and the propeller are undergoing their own independent certification processes, running in parallel with the airframe certification. This isn't a coincidence. It's a deliberate, strategically coordinated approach. By synchronizing all three certification tracks, the program avoids one of the most common and costly traps in aircraft development, having a certified airframe with no certified engine to put in it, or vice versa. Every component arrives at the finish line together. But there's a bigger idea here. Every major component of the Baikal, from the turbine internals to the propeller hub, is designed and manufactured within Russia. In the current global environment, where supply chains have become geopolitical leverage, that self-reliance isn't just national pride. It's strategic insurance. And it sends a clear message. This program isn't dependent on anyone else's timeline. anyone else's components, or anyone else's approval. That's an important statement to make. But making a statement and delivering on it are two very different things. Step back from the engineering for a moment, because the real stakes of this program aren't technical. They're human. Russia's geography is extraordinary and extraordinarily challenging. Enormous regions like Yakutia, Chukotka, and the Kamchatka Peninsula are simply not accessible by road. In winter, some communities can only be reached by air or by ice road. For these populations, a functioning regional air network isn't a convenience. It's how medicine arrives. It's how children reach schools. It's how emergency services respond when something goes wrong. The An-2 carried that responsibility for generations. But an aging fleet, vanishing spare parts, and tightening safety regulations have quietly eroded the network it sustained. Routes have been cut. Communities have become harder to reach. The gap between Russia's connected cities and its isolated interior has been slowly widening. The Baikal is being built to close that gap. Better fuel efficiency means lower operating costs for regional carriers who currently run on razor-thin margins. Lower maintenance requirements ease the burden on remote facilities that often lack specialized technical support. And improved passenger comfort reflects something simple but important, that the people living in these communities deserve the same basic standard of travel as anyone else. This aircraft, if it succeeds, doesn't just fill a market gap. It reconnects people. And that's a weight that no spreadsheet fully captures. Here's where we have to be honest about the road ahead. The target is bold. Full certification completed by the end of 2026. Commercial service entry shortly after. For a program of this complexity, developed domestically under significant external pressure, that would be a remarkable achievement. The Ural Civil Aviation Plant is already preparing upgraded assembly lines and enhanced quality control systems in anticipation of full-scale production. That's a signal of genuine confidence. But it also adds stakes. Production preparation costs money. Every month of delay carries a real, measurable cost. And delays? In aviation certification, they happen. Always. A single unexpected finding during structural testing. An engine performance dataset that requires additional verification. A regulatory review that demands more documentation. Any of these can shift the timeline. That's not pessimism, that's just how rigorous certification works. Scaling from prototype to mass production adds an entirely different layer of risk. Manufacturing consistency, supply chain management, workforce capacity. These aren't engineering problems, they're organizational ones. And they're just as capable of derailing a program as a failed stress test. What happens next is critical. But here's what's also true. The Baikal has already cleared hurdles that many doubted it would. The program is further along than its critics predicted. The conversation has quietly shifted from can this aircraft be built to how quickly can enough of them be built. That's not a small thing. The LMS-901 Baikal is, technically speaking, a light turboprop with a regional mission profile. But watch this program closely, really closely, and it becomes something much larger. It's a statement about technological independence. It's a commitment to communities that modern aviation infrastructure has largely left behind. And it's a genuine test of whether a country can rebuild an entire segment of its aviation ecosystem from the ground up under pressure on schedule. The An-2 lasted nearly 80 years. Think about that. Nearly 80 years of service. The aircraft replacing it carries that legacy, not just in its design requirements, but in everything it means for the people waiting for it. Will the Baikal meet its 2026 certification deadline? Will it deliver on the operational promises being made? And can Russia actually build these aircraft at the scale the country needs? Those questions don't have answers yet. But what's already clear is this. The program is real, the progress is measurable, and for the isolated communities scattered across Russia's vast interior, the stakes couldn't be higher. For them, this isn't an aviation story. It's a lifeline they've been waiting for. So, do you think the Baikal will actually deliver by the end of 2026? Or are there too many variables in play? Drop your thoughts in the comments. I genuinely want to hear what you think. And if this kind of in-depth breakdown is what you're here for, subscribe, share this with someone who follows aviation, and hit the like button. Takes 2 seconds and it makes a real difference. See you in the next one.